Chapter 4, The Change Begins. Nearly all 97% of climate scientists agree. Humans and their impact on the earth are making the difference. The principal geologist at the British Geological Survey explained, "We have had an incredible impact on the environment of our planet." Another geology professor later added, "We are just realizing the scale and permanence of the change." Recent human activity is the reason why Earth is warming and also why it's happening at such a rapid rate. Some feel we should even mark this as a new era, much like the age of the dinosaurs, the age of humans. Recent human activity refers to the past 200 to 250 years when technology began hugely changing the way people live. It all began with the revolution, although one that wasn't a war. The Industrial Revolution was a time of new ideas and new inventions. In the United States, it started in the late 1700s with one cotton mill in Rhode Island. More factories followed. Earlier, mostly everything had been made or built in homes or small workshops. People spun their own thread, sewed their own clothes, and made their own candles. With new machinery, production, which means making things, shifted to large shared spaces, factories. These factories were powered by coal. They produced large amounts of goods fast. It became easier to buy factory-made items, clothes for instance, than to sew them by hand. Soon, factory-made gas lamps replaced homemade candles. Then, electricity replaced gas lamps. In time, whole cities needed electricity. Power plants were built to supply electricity to great numbers of people. These stations converted energy sources, coal and oil, to electric power. In homes, fireplaces were no longer needed to provide heat. Burners and furnaces were developed to keep houses warm. They used oil and gas. Coal, oil, gas, all are fossil fuels. They're natural resources that come from long-buried plants and animals, ancient life forms that held carbon. When they're burned to generate power, they release the carbon as CO2. By the early 1900s, horses were traded in for cars. For long-distance travel, people took trains, and by the 1930s, flew in airplanes. These forms of transportation burned coal and oil and ran on electricity from power plants. All needed fossil fuels, and all emitted CO2. It's those CO2 emissions from factories and power plants, cars, trains, and airplanes that send extra greenhouse gases into the atmosphere. Using fossil fuels creates dirty energy, polluting the air with climate-changing gases. Clean energy, on the other hand, causes little emission pollution, and renewable energy has practically zero. Renewable energy. Energy from sources like wind, water, and the sun is called renewable energy because there is an endless supply of it. For solar energy, special glass panels capture the sun's power and convert it to electricity. Different kinds of turbines, windmill-like structures, use the wind or flowing water from rivers, streams, and waterfalls to spin blades and generate power. Unlike coal, oil, and gas, all these sources produce clean energy that doesn't pollute or emit greenhouse gases. During the Industrial Revolution, and even afterward, no one thought about the amount of fossil fuel emissions. No one wondered if all that CO2 would bring harmful consequences, not even scientists who knew about greenhouse gases. As far back as the 1820s, scientists understood that CO2 absorbed heat and helped keep the planet warm. Then, in the 1890s, a Swedish scientist named Svante Arrhenius, along with his co-worker Arvid Högboom, came up with a new idea. Could all that CO2 that came from factories be making a difference in temperature? Using math, Arrhenius came up with the first climate model. The first study to predict how temperature would rise and greater greenhouse gas emissions. Other scientists studying the climate didn't think much of Arrhenius's findings. His model showed that if CO2 increased 2.5 minus 3 times the level it was then, temperatures in the Arctic would rise about 8 to 9 degrees Celsius. In other words, he argued that human-made CO2 had a great influence on Earth's heat. Other scientists questioned whether humans could have such an impact. The planet had been around for billions of years. Climate had changed before human beings ever existed. They thought that more greenhouse gas emissions might make temperatures go up, but just a bit, no big deal. In addition, scientists had proven that oceans absorb CO2, so wouldn't most of that extra gas be soaked right up by water? But in the mid-1950s, an oceanographer named Roger Reville ran some experiments and discovered that oceans have a limit to how much CO2 they can take in. Also, they absorb it much more slowly than anyone had imagined. That meant temperature could rise quickly. In turn, rising temperature could change the delicate balance of Earth's environment. It became important to measure and measure accurately CO2 levels in the atmosphere to see if Earth's climate was in danger. Chapter 5. Measuring Up. Scientist Charles David Keeling of Scripps Institution of Oceanography helped develop ways to take those CO2 measurements. He set up stations far away from cities and factories. He purposely didn't choose places near areas with higher than normal CO2 levels. That would throw off the findings. One station was in the Antarctic, the other high on a volcano in Hawaii, a New York City power plant from the early 1900s. View of Reed Glacier in Glacier Bay, National Park, Alaska, 1956. Another view of Reed Glacier in Glacier Bay National Park, Alaska, 2013. Look at the differences. A polar bear waits for Hudson Bay to freeze over, 2007. Teenagers in an Alaskan village hopping onto melted sheets of ice. The Mauna Loa Observatory in Hawaii. The South Pole Observatory. The March for Science in Washington, D.C., 2017. The first Earth Day event on the front page of the New York Daily News, 1970. A woman paddles down a flooded road during the aftermath of Hurricane Harvey in Texas, 2017. A young Kenyan boy stands on a dried up riverbed, 2009. A raging wildfire in California, 2017. A bleached reef in the Great Barrier Reef, Australia, 2003. Workman at a natural gas plant, 1946. Wind turbines spin behind a field of solar cell panels in Germany. Mauna Loa Observatory. Built into the side of Mauna Loa volcano, this research center sits 11,135 feet, more than 2 miles above sea level. It's the longest running CO2 measurement station in the world. Findings are plotted on the Keeling curve, a graph that has become a symbol of human impact on climate change. Daily measurements are posted on the observatory website. Check the bibliography in the back of the book to get the website link. Give you the link really quick. In 1958, the first results came in from both observatories. CO2 levels stood at 310 ppm parts per million. That means for every million bits of gas in the atmosphere, 310 of those bits were CO2. In the 1700s, CO2 levels had only been about 280 ppm. The jump didn't seem too significant. It was far from an unsafe level. But what if it was a trend and the levels kept rising? The South Pole Observatory closed, but Mauna Loa measured CO2 levels year after year. Soon it became clear the levels were rising even higher. Again, outside of Keeling's group and a small number of scientists, no one felt alarm. In the early 1960s, scientists started using computers to predict Earth's climate in the future. Newer, more advanced models were developed over decades. To test them, scientists put in information about the atmosphere, rainfall, and other factors from past years that already had a climate record. By the 2000s, the models proved accurate again and again. They not only predicted Earth's climate future, they explained Earth's climate past, and each model pinpointed greenhouse gases as the cause for recent warmings. In 2011, one model estimated that at least 74% of climate change since 1950 was due to human activity. Meanwhile, the global population had been growing steadily, so there were more people who needed cars. More factories were needed to produce goods. Forests were cut down to make more living space. By 2016, the CO2 level hit 400 ppm. That was the highest it had been in 4 million years. The news made headlines. Scientists realized warming was happening faster and faster. Disappearing rainforest. Rainforests are thought to hold half of all the different life forms we have on Earth, but thousands and thousands of acres of forest are lost every day, threatening wildlife. Trees are cleared to make way for homes and farms, and also to provide wood. High temperatures and long dry periods destroy rainforests too. All those downed trees release great amounts of CO2 and no longer give off oxygen. That changes the carbon cycle balance, further warming our climate. Chapter 6: Vicious Circles. Everything about the climate on Earth is connected. For instance, ocean currents affect air temperatures. Air temperatures affect plant life. Plant life affects the atmosphere. The atmosphere affects ocean currents. It comes full circle. To put this idea in general terms, A makes a change in B, which in turn changes A, which changes B even more, and so on. It becomes a vicious circle, a never-ending loop. Melting ice and snow are one example. Ice and snow are clear and white. They act like mirrors, bouncing sunlight off their surfaces to keep Earth cool. But when temperatures rise, sea ice, along with land ice and snow, melts. There is more open ocean and more uncovered land. Both are darker than snow and ice. Have you noticed that when you wear a black shirt, you feel warmer in the sun than if you wear a white one? Dark colors soak up heat, so the darker ocean and land act like sponges, absorbing energy. That extra energy warms Earth, which causes temperatures to rise, which means more ice and snow, which exposes more ocean and land. The effect is especially serious in the Arctic tundra, where permafrost is disappearing. The permafrost, which has been there for millions of years, holds methane. That is another greenhouse gas, one even stronger than CO2. Methane doesn't stay in the atmosphere as long, but it traps about 30 times more heat. When the permafrost melts, methane is released. The temperature goes up, and more permafrost melts, releasing more methane, and so on and so on. The more Earth warms, scientists realize the quicker more warming occurs. In other words, high temperatures lead to even higher temperatures. It's one more factor in the science of climate change, but some people don't believe in the science. They don't believe in climate change at all. Chapter 7. Is it real? Scientists are always questioning their own findings, always exploring different possibilities, always retesting the results of experiments. How they investigate climate science is no exception. So even climate scientists don't agree on all the details of global warming. That makes some people question everything. Climate scientists say they've proven. Some people even say climate change is a hoax, a lie, a trick. They think there is no climate change, just weather, which changes as it always has. Day to day, climate change is hard to see. Even if you're suffering through the middle of a heat wave, for instance, it could just be a bad stretch of natural weather. It's true there have always been years with very severe heat waves, but with global warming, heat waves are more likely to happen and be worse than in years past. Warming may not be the cause of every event, but emitting more greenhouse gases increases the odds of extreme weather. Almost all climate scientists agree on that and some other basic facts. Earth is heating up. It's because more and more greenhouse gases are being released through fossil fuels into the atmosphere. People are responsible for this. Still, to argue against the facts, some people bring up climate changes of the past, that Earth has always gone through cycles. During the dinosaur age, CO2 levels were much, much higher. Some people believe that explains what is going on now. But remember, top scientists agree that given Earth's natural cycle, the planet should be cooling. They also say the sun is sending out less energy, yet Earth is still warming. Then there are some people who agree that, yes, human activity is causing the planet to warm, but they say that this is no cause for alarm. Plants, life, animals, and humans can adapt to this climate change. After all, they have in the past. However, Those people are forgetting that earlier warming periods stretched over thousands and millions of years. Every form of life had time to change, to fit into a changing environment. Now warming is happening at a much faster rate. Some people may accept all the science and even worry that Earth will not adapt to this current climate change. But even though the warming is dangerous, they say it's not harmful enough for people to switch the way they use energy. People don't want to give up their modern lifestyles and also don't want to change to using clean energy instead of fossil fuels. People don't want to switch to using clean energy instead of fossil fuels, which are often less expensive. Certain businesses that rely on fossil fuels feel the same way. They don't want the government to pass laws limiting the release of CO2. So climate change isn't just a scientific issue, it's a political one too.